Okay, so this is the first lesson on the chapter 2 homework stuff. We're going to go over the distance and midpoint formulas. I'm going to go back and forth from stations because a couple of these have a lot of math and it's not really easy to write on this board. So the first question, if 3 and 4 are the legs of a right triangle, the hypotenuse is. So this is a refresher of the Pythagorean theorem. So we have a squared plus b squared equals c squared, where a and b are legs. And it doesn't matter which one's A and which one's B. Just know that it's the shorter of the two sides of a triangle. And C is going to be your longest side, which is also known as the hypotenuse, which is what they're asking for. So to find the hypotenuse, we take our two shorter sides, which are the legs, 3 and 4. So I'm going to have 3 squared plus 4 squared equals c squared, which is the hypotenuse. So 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. So c squared equals 25. And then we take the square root of this. Remember though, this is an actual distance, so we're not going to have the negative answer because distances cannot be negative. So c equals 5. All right. The distance between 2 points is sometimes a negative number. Distances cannot be negative. Distances cannot be negative. So false, because it says sometimes a negative number. Distances cannot be negative. This is going to be our distance formula we're going to use on the next parts. I'll probably write it down up in the corner and not erase it for a while. Plot 5, 3, 0, 4, 6, negative 6 in the XY plane. This is a refresher on graphing. So our first one says 5, 3. I want to show y'all these without having to zoom in on all of them. Here we go. This one, remember when you go to graph, 0, 0 is always your middle point. So this right here is 0, 0. This is where we start when we graph. The first, when they give us a point, I'll write it over here. This is what we're looking for. So x is first. This is the x-axis. Y is second. Y is on the up-down axis. So a positive 5 would be right 5 from this 0, 0. Negative 5 would go left. Then positive 3 would go up 3, where negative 3 would go down 3. So the point they have on this one, it goes right 5, but then they go down. So this would be 5, negative 3. This one here goes negative 5 and then down 3. So this would be negative 5, negative 3. So it's not that one. This one is negative 5 because it went left from our center. And up 3, so this is negative 5, positive 3. And so here is our lovely answer. They went right 5, and then they went up 3. And since ours is positive 5, positive 3, it's going to be in this area. Before we move on, though, real quick, the next question is going to ask about quadrants. So when we do our quadrants, this is quadrant 1. This is quadrant 2, 3, and 4. So they go counterclockwise when they list our quadrants. You need to know this. And I need to erase that. So our graph was this one. Check. And then that was in quadrant 1. And they'll use Roman numerals. Choose the graph that correctly plots 0, 4. So our x is 0, so it's not going to move from the center. And it's a positive 4, so we're going to go up 4. Let's look at this graph. This is 0, negative 4. This is negative 4, 0. So x was negative 4. And y didn't go off the axis, so that's not it because we're looking for 0, 4. Here, it didn't leave 0 on the x-axis and it went up 4. So this is our graph. Check answer. On which coordinate axis does the point lie? So was it on the x-axis on the flat part, or was it on the y-axis up and down? Ours was on the y-axis. Doop, doop, doop. Choose the graph that correctly plots the point 6, negative 6. So positive 6, so right 6, and then since it's a negative 6, we're going to go down 6. So right 6, down 6. This one went right and up, so it's not that one. This one went right and down. This is our graph. This one, they went left and up, so this would be negative 6, positive 6. This one, they went left and down, so that would be negative 6, negative 6. Ours was positive 6, right 6, down 6. And that puts this one in the 4th quadrant, which is IV when you're doing Roman numerals. Okay. Plot the points 7, 0, 7, negative 4, 7, 2, 7, 6, 7, negative 6. Describe the set of all points of the form 7y, where y is a real number. Okay, here we go. Actually, I don't want to do it big. 7, 0, which is just going to be right 7. Can I try that? Oh. One thing when you're doing these, you'll realize it's super touchy. So we're going to go 7 again, right 7, down to negative 4. It moved to 6. Be sure you pay attention on that. It's not doing that. Let's see if I can. But that's 7, negative 5 now. Yuck. Okay. 7, 2. You're going to stay there. 7, 6. Right 7, up 6 to positive 6. It does have the little guidelines now. I don't remember it doing that always, because that was, you would think that you're on the right one, and it wouldn't be. Like, it keeps popping to negative 7. Okay. All right. Describe the set of all points of the form 7y, where y is a real number. The points are on a horizontal line. Remember, horizontal is left and right, so it's not horizontal, so it's not A or C, because those both say horizontal. So the points are on a vertical line, which is up and down. That's what we have. 7 units to the right of the axis, the y-axis, or 7 units to the left of the y-axis. So here's our y-axis. It went to the positive right. Yeah, all the parts are done, so we're going to go ahead and go to the next problem. Here we go. Here's our first distance problem. The first few, they give us a graph so that we can look at it. What I want to show you on this is when they give you the graph, if it's that diagonal, we're finding the hypotenuse by doing this Pythagorean theorem. So we find the legs, which are these two values, and then we're going to take the square root to get this, the a squared plus b squared equals c squared. It comes into this, but now then we're using actual points, and our point is 0, 0, so we have this one, and we have 6, 5 here. So to be able to find this distance right here, we have to find the difference in the values. So we have 0 and 6 here. So it's going to be like 6 subtract 0 to get how many this is. And over here we'd have 5 subtract 0. And then we use this value, so we'd have 6 here, 5 here. And so when we go to find this, these are the shorter sides. We'd have 6 squared plus 5 squared equals c squared, where that's 36 plus 25 equals 36 plus 25, that would be 1, carry the 1, 3, 4, 5, 6, 61. So c squared equals 61. Where do I want to write that? And then we'd have to take the square root, but remember it has to be positive because it's a distance. So c would equal the square root of 61. Sometimes you will have numbers you can actually take the square root of that you can simplify. This one is not one of those, and that is not a bad thing. Now, I want to show you this exact same thing using the actual distance formula. I wanted to show y'all where the distance formula came from on this one since they gave us the origin. But let's use the formula. Okay, I want to write the formula up here in a different color to keep it here. So let's do distance equals the square root of x2 subtract x1. I'm not going to have room to write that. Distance equals the square root plus and all that's under that square root, that, well, square root. Gosh dang it. Okay, well, here we go. So you take x2, which is going to be from our point 2 right here. x2, and this is x1 from point 1. And then y2 comes from point 2, and y1 comes from point 1. And when I go to work this out, distance equals the square root of x2 subtract x1, 6 subtract 0 squared, which we did, plus y2 subtract y1, 5 subtract 0 squared, all under the square root, which we did all of this, we just didn't do it in the distance formula. So 6 subtract 0 is going to give us 6 squared. 5 subtract 0 is going to give us 5 squared. And then we're going to square them, so we're going to have the square root of 36 plus 25. Which is going to be the square root of 61. And since that doesn't simplify, that's our answer. So the Pythagorean theorem was used to create the distance formula. Okay. I'm going to do a bunch of these over on the whiteboard in a second, but let me go ahead and type this one. So if your radical doesn't simplify, like if you type it in your calculator and it gives you this huge decimal, because it's an improper number, you're going to just type that in there. There's some of these that simplify. The TI-30 XS Multiview is a wonderful thing when working these. This problem, we'd have you have this distance, and then you're going to square them and take the square root, square them, add them, square root to get this. We're going to use the distance formula because we're going to have to use the distance formula in a minute. So we have x2 and y2, x1 and y1, and then distance equals the square root of 1 subtract negative 6 squared plus y2 subtract y1 squared. Okay, well, distance equals the square root of this. When you subtract a negative, you add. So 1 plus 6 is 7 squared. Plus 4 subtract 2 is 2 squared. And if we counted here, we'd have 1, 2, 3, 4, 5, 6, 7. And that one's 2. So 7 squared plus 2 squared would give us 49 plus 4. And then 49 plus 4 is 53. So this one doesn't reduce either. When I'm looking for something that reduces, I'm looking at like my squares that go into it. So like 2 squared is 4. 4 does not go into 53. 3 squared is 9. 9 does not go into 53. 4 squared is 16. That doesn't go into 53. 5 is 25. 6 is 36. 49. So there's no square that goes into 53, so I can't reduce it. I'm fairly certain we have to in a second. So I'll show y'all when we get there. Yuck. All right. I'm going to write the formula right here now. Squared plus y2 minus 1 squared. Cut that part out, please. Okay. So this is going to be our x2, y2, x1, y1. So we have distance equals square root of 3 subtract negative 1 squared plus, and it's always, you're adding whatever the difference between your x and your y is together, 4 subtract 1 squared. So distance equals, when you subtract a negative, you add it. So 3 plus 1 is 4 squared. 4 subtract 1 would be 3 squared. 4 squared, 16. And 3 squared is 9. So 16 plus 9 is 25. So distance equals the square root of 25. So D is 5. Thought I could finish doing it over here. Don't like this board. I accidentally hit a 3 there. Okay. So they wrote these sideways now, so we have x1, y1, x2, y2. Distance equals the square root of 6 subtract negative 4 squared plus 0 subtract 3 squared. 6 subtract a negative 4, you'd add it. So we're going to have 10 squared plus negative 3 squared. When you square a negative, it becomes a positive. So we're going to have 10 squared is 100. 3 squared is 9. So we have 109. Does that reduce? Four wouldn't go into 9 evenly. 9 won't go into that evenly. 16 won't. 25 doesn't. 36 doesn't. 49 does not. Next is 64, then 81, and then 100. So I think we have square root of 109. This is the long problems. There's not one of these on the test, but if you can do this problem, you will get all of them that you will see that are distance problems. But first, they want us to pick the graph that has all of these. So we're looking for -6, 6. So that's left 6, up 6. There's nothing that's left 6, up 6. No left 6, up 6. No left 6, up 6. So this is the only one that has -6, 6. Okay, so on problem 9, I graphed it over there, and I'm going to show y'all how to work it over here so I have more room to write, because there's a lot to write. Okay, so first I'm going to go ahead and give us our points. A was -6, 6. B is 1, 0. And C is 2, 2. Now I'm going to go ahead and give us our distance formula before I get too far into this, just for easy viewing. So distance equals the square root of x2 subtract x1 squared. I'm going to change that easily. Plus y2 minus y1 squared. Okay, so we're proving the right triangle. So to be able to prove it, we have to prove that there's 2 legs, and the sum of those 2 legs equals the longest side because of the Pythagorean theorem. So let's go ahead and start finding the distances. So let's do AB first. And I'm going to have distance equals the square root of 1 subtract -6, all of that squared, plus 0 subtract 6 squared. And that's going to be AB, so let's go ahead and do it. I'm going to scoot it under. It equals the square root of 1 subtract a -6 would end up being 1 plus 6, which is 7 squared, plus, and this would be -6 squared. 7 squared is 49. 6 squared is 36. So 9 and 6 would give us a 5. And then we'd have a 185. That looks a little weird, but it'll be all right. Then we're going to have AC. So distance between AC, we have x2 subtract x1 squared plus y2 subtract y1 squared. Go ahead and work that. We're going to have 2 subtract a negative. When you subtract a negative, you add. So 2 plus 6 is 8 squared. 2 subtract 6 here would give us -4 squared, which is going to be 64 plus 16, which is 70, 80. This one reduces. I'm going to put a, I'll come back to this. Let's go ahead and get our last one is BC. So the distance between points B and C is going to be x2 subtract x1 squared plus y2 subtract y1 squared. Okay. Work that out. 2 subtract 1 is going to be 1 squared. 2 subtract 0 would be 2 squared, and you always add your 2 squares. 1 squared is 1 plus 4, so our distance here is going to be, I think I left the distance off all of them except for that one. ADHD, y'all. Okay, now then, let me read it exactly how it says it, so not to confuse you. It's going to ask for the length of each line segment. So this is, if it doesn't simplify, you put this in. So our length of AB is the square root of 85. Our length of AC is going to reduce. So let me show y'all that now. If you type in the square root of 80 right here, it's not going to take this answer because you have to simplify it. So, I don't want to say this without just giving it away. You're looking for something that has a square root that goes into 80. So like 4 goes into 80. So I could use 4. 9 does not go into 80. 25 does not go into 80. 16 goes into 80. If you have one of those TI-35, TI-30 excess multi-views, those will work and do, if you type in this part right here, it would give you the answer. And this is going to simplify because 16 goes into 80 5 times. And then the square root of 16 is 4. So these two right here are equal. But this is going to be the answer that they're going to take. They won't take the square root of 80 for this because it is not simplified. And they want it in simplest form. Simplify your answers. Type exact answers using radicals as needed. That means they're not going to take decimals. And then BC is square root of 5. And that's what they want on that one. I don't really want to type them all in, but I need to see what the next words are. It's my keyboard. Okay, square root of 85. Next. I just want to be able to tell you all the exact words it's asking for. Oh, the next part, it says find the square distance of each segment. So square distance. So it's going to be like the square distance of AB would be the square root of 85 squared. What they want in that box is 85. This one, it'd be 4 square root of 5 squared, but we know that 4 square root of 5 is 80, so the square root of 80 squared is 80. That's what goes in that one, and then the square root of 5 squared is 5. So this is what they want on the squared distance, this over here. Okay, so 85, 80... Next part they asked for is the sum of the squares of the lengths of the legs. So, sum of legs. I'm going to simplify that. Sum of squares of the lengths of the legs. That's the whole thing. Okay, so we look for our 2 shorter sides. So the 2 shorter sides would be 80 and 5. And so this one is 85. And then they're going to want the square of, how do they say it? The hypotenuse. I'm going to put squares here. Sum of the squares of the legs. Sum, and this is the square of the hypotenuse right here. And that's just going to be 85. So right there, that's the whole thing they wanted us to do. By proving that these two are equal, we have proved that this is in fact a right triangle. And then the last question is the area of the triangle is blank square units. So area of a triangle is 1/2 base times height. So we're going to have 1/2 times our 2 shorter sides, which was right here, because this one's 80 and this one's the square root of 5, so times 4 square root of 5 times square root of Okay. Doing this, I do 4. We'll go ahead and do 1/2. And then we're going to have our 4. And then we'd have the square root of 25 now. Square root of 25 is, I'm going to run out of room. 5. 4 times 5 is 20. So half of 20 is 10. I don't even know if you can see that. But this is 10 for this problem because of this. If you have your calculator and you type that in, it'll give you that. So I'm going to go ahead and start by writing the midpoint formula up here. Remember that the midpoint formula is pretty much the average of 2 points. We're finding the middle, the midpoint, between 2 points. So it is, you add your x's and divide by 2. Then you add your y's and divide by 2. Just remember, x's go together and y's go together. So this part's not bad. And it's going to be wrote as a coordinate point because you were finding a point. Before we were finding a distance, so that's why there was 1. But here we're finding that middle value, so you're going to have a point. So here, our first one, we have 0.1 is -2, 4. And 0.2 is 7, 0. If it is, if it's not divisible by 2, leave it as a fraction. So we'd add our two x values, so we're going to have 7 plus -2 over 2, and then we're going to have 0 plus 4 over 2. So 7 plus -2 would be the same as 7 subtract 2, so we're going to end up with 5 over 2 there. And then 4 over 2 would be 2. And that would be your answer. And remember, it's an ordered pair, so you have to put your parentheses with it. Okay. Done with that this one. This one, they have 0.1 is 4 -4. And 0.2 is 8, 4. So we add our x values, 8 plus 4 divided by 2. And then we're going to add our y values, 4 plus -4 divided by 2. 8 plus 4 would give us 12 over 2. 4 plus -4 would give us 0 over 2. And then divide. 12 divided by 2 is 6. 0 cannot be divided. And remember, you have to write it as an ordered pair. Let's do another one. This is question 13 on this assignment. So it has 0.1 is AC, and it has 0.2 is 0, 0. This is just kind of a check on the formula because you'd have your x's, you'd add them together, so I'd have 0 plus A divided by 2, and then I would have 0 plus C divided by 2. I'm adding nothing to it, so I have A over 2 and C over 2, and then write it as an ordered pair. Then our last one. Oh, there's a couple more. Oh, okay. Well, that's all of the midpoint ones. I'm gonna have to do so much editing on this video for 2.1 because I'm out of it. Oh, question 14, it says, if the point 0.16 is shifted 5 units to the right, so I'm going to put 5 units right and 4 units down. What are the new coordinates after all that shift? Oh, shift, I said shift. 5 units right. That's going to be an x change. So 5 units right would be a plus 5 to the x value. If it was left, it'd be subtract 5. 4 units down, we're going to subtract 4 from the y value. If it would have been plus 4, we would have added 4 to it. So I'm going to have 1 plus 5 for my new x value, which is going to be 6. And then I have 6 subtract 4 for my new y value, which is going to be 2. So this would be what they want. I hope that makes sense. And then we have one more problem. Find all points having an x-coordinate of 3 whose distance from the point -1, -6 is 5. So this is a distance problem. So let's get all of our information up here first. Distance equals the square root of x2 subtract x1 squared plus y2 squared. All right. They tell us find all points having an x-coordinate of 3 whose distance from the point -1, -6 is 5. So we have a point -1, -6. We're looking for everything that's whose x, find all points having an x-coordinate of 3 whose distance from this point is 5. So D equals 5. All right, we have everything but one y value for this, and I can label those right now. We'd have x2, y2, x1, y1, and this is D. So let's set it up. 5 equals 3 subtract -1 squared plus y2 subtract, I don't need to put the 2 here, it's just y, subtract -6 squared. So 5 equals the square root of, this would be 3 plus 1, so I'm going to have 4 squared plus, I'm going to go ahead and change this just to y plus 6 squared. Now, we have to square that, and when we square this y plus 6 right here, I'm going to remember that this is this. So y times y is y squared plus 6y plus 6y plus 36. So y squared plus 12y plus 36. That's what has to go in right here for y plus 6. So I'm going to have 5 equals the square root of 16 plus y squared plus 12y plus 36. And then I'll combine these two. So I have 5 equals the square root of y squared plus 12y plus 36 plus 16 to carry the 152. Now to get rid of a square root, we have to square both sides. So 25 equals y squared plus 12y plus 52. And then we would subtract our 25. So, because we're putting it into the quadratic equation now, so we need it to equal 0. 52 subtract 25 would be 27. Factors of 27 that add to get 12. I'm going to go ahead and write this up here. Y. All right. Now our factors of 27, we have 1 and 27. 2 does not go into 27. 3 goes into 27 9 times. 4 doesn't, 5 doesn't, 6 doesn't, 7 doesn't. These are the only factors of 27. So which set of these add to get 12? Right here. And they're both going to be positive. So I'm going to have y plus 3 and y plus 9 equals 0. Set both factors equal to 0. Subtract, solve them. Now, this is just the y values they ask for the 2 coordinate points. Our x value on this coordinate point is 3, so our actual answer is going to be 3, -3, comma 3, -9.